this is Adam Griffin with the first video for this week, and we are going to be doing problem number 2, which says that we have to use Kepler's laws to find an expression for the ratio of the radius of the moon's orbit around the Earth to the Earth's radius, which is q. And then we give our answer in terms of the acceleration due to gravity, the period of the moon around the Earth, and the Earth's radius, and we evaluate our expression once we have figured it out. So right here I wrote down all of the variables that we will need to include in our equation, and then I rewrote what q is equal to. So it's equivalent to the radius of our orbit, rm, divided by the radius of Earth. So according to Kepler's third law, the orbital period squared equals 4 pi squared times our orbital radius cubed divided by the gravitational constant times the mass of the center object, so in this case Earth. So we can take that and we find an expression for just Tm, which is equal to the square root of this this term. So also from Newton's laws of gravity, we have our g, our little g, which is our acceleration due to gravity, is equal to our gravitational constant times the mass of Earth divided by our orbital radius squared. So we can actually plug this in because you can just flip these and it's equivalent to 1 over g. So we can plug that in right where there's the gravitational constant and the mass of Earth, and it will give us that our orbital period is equal to the square root of 4 pi squared times our orbital radius divided by gravity. So once we have that, we can rearrange this and find this term, which is equivalent to the radius of our orbit. And once we have that, we know that since q is equal to the radius of our orbit divided by the radius of Earth, all we have to do is divide this term by the radius of Earth, and we get our final equation, which is our orbital period squared times gravity divided by 4 pi squared times our radius of Earth is equivalent to the ratio between the radius of our orbit and the radius of Earth. So we can evaluate that with all of these variables up here that they give us, and be sure to convert this to seconds. So we plug all of these in and we get our ratio of 217,000. So that is how you do number 2, and thank you.